In this chapter, you will understand how to describe geometric figures, measure them, and be able to understand congruence and equality. In this picture, it shows segment addition postulate. It shows AB plus BC, and it equals 14, which is the length of X. This would be a representation of a real-life application of Chapter 1. If this cliff guide, climber, and if he was 5 feet up the cliff, and the cliff is 12 feet high, how high is X? That's something that you could find out in the real world and find out how high you have to climb. In this chapter, you will conquer inductive and deductive reasoning. You will be able to write proofs and understand geometric relationships. Right here is a proof. It's how you would set it up, and then you would write the equation and the reason of why it is what it is. A problem in this chapter that could come up is, would these two triangles be congruent? And the answer is yes, because of angle side angle, and you would be able to prove that with a proof and reasoning. In real life, you could use this as a proof, I guess you could say, to prove if these two buildings, city buildings, are congruent because of all the theorems and stuff in this chapter. So you could prove that these two buildings are congruent. In this chapter, you will learn to use parallel and perpendicular properties. You will be able to use them in proofs and connect all of it to last year, what you did in algebra. So this is a problem that could pop up in Chapter 3 quiz or something. The question would be, what angles in this transversal are congruent? And the corresponding colors show that which angles would be congruent, I guess you could say. And the triangles show that each line are parallel to each other, because that's the only way that it would be a transversal. If these lines weren't parallel, this one and this one, then the transversal wouldn't even happen. This is a real life application of Chapter 3. If this building was not perpendicular to the ground, then the chance of it standing up would be a lot less, because it would not be as stable. So you have to have perpendicular lines when making buildings, and the windows, if they're not parallel, then that could mess up the shape and design of the building, so it would make it not look as well. Chapter 4 is all about triangles, classifying them, telling them if they're congruent, and using a graph to identify them. This triangle, all three sides are congruent, so it's an equilateral triangle. This triangle has two congruent sides and a right angle, which makes it a right isosceles triangle. And then this triangle right here has no sides congruent, so it is classified as a scalene triangle.
This is Chapter 5, Relationships within Triangles. In this chapter, we learn how to use properties of special segments in a triangle. We learn how to use triangle inequalities to determine what triangles are possible, and other methods for justifying and proving relationships. In the real world, if you're building a structure that is like a triangle shape, and you had to support it, you could find the center of a triangle, or tell if a wall or something is perpendicular to the triangle, or if you're if you're walking somewhere and you want to know how far you've gone, you can just draw a path like the one in the picture and figure out how far away you are. This is chapter 6 called Similarity. In this chapter we learn how to use ratios and proportions to solve geometric problems. We learn how to show that triangles are similar, and we learn how to use indirect measurements to prove that something is similar. You can use proportional reasoning to estimate the height of anything, like if you're building a scale model of a building, you have to make sure that your model and the real thing is similar. Chapter 7 is called Right Triangles and Trigonometry. In this chapter we learn how to use the Pythagorean theorem and its converse. We learn about special relationships in right triangles, and we learn how to use trigonometric ratios to solve a right triangle. You can use right triangles and its ratios to find the distance that you travel if you're traveling like down a hill or a mountain. 8 was called Quadrilaterals, and that's what it's all about. It's about the different types of quadrilaterals and the properties that are associated with them. In this chapter we learned about angle relationships in polygons using properties of a parallelogram and classifying a quadrilateral by its properties. In the real world, an architect might want to find angle measures of a building to make sure that everything will line up and be square so that a building will be stable.
Okay, this is chapter 9. This is the properties of transformations, and it's performing congruence and similarity and making real-world connections to symmetry and tessellations. And it's pretty much all about the transformations and translations and reflections and rotations and all that. And a way you could use this in the real world is if you're building some structure, big or small, and so say you have half of it and you need to get it completely symmetrical the other side, then you would just get the angles and all of the sides and you would just make it the exact same. I mean, even though that's not the same, you would just make it the exact same as the other side. So pretty much if you flip the other side over, it would work. Okay, this is chapter 10. This is the properties of circles, and it's literally just everything about circles, all the properties and everything about all that's congruent in it. It's using properties of segments that intersect circles, applying angles, relationships in circles, and using circles in the coordinate plane. And it's pretty much just all of that. And then one way that you can use this in the real world is by using the arc addition postulate. So if you have, this is just a circle, but if you have like a circular room or something like that, and I need to figure out how long around the room is, so I could just say, well, I have something right here, and I also have something right here, and I need to find right here, but I also have something right here, and I need to find what this is. You can just find what the total is, and then you would just add this right here, and then you would add this right here and subtract it from the main, and that's pretty much the arc addition postulate. Okay, this is chapter 11, and this is measuring length and area, and this is all about pretty much just length and area and all the polygons, and using the different formulas for like trapezoids and everything to find length and area. And the main ideas are using area formulas for polygons, relating length, perimeter, and area ratios in similar polygons, and comparing measures for parts of circles and the whole circle. And one way you can use this in the real world is, hold on. Is if you have like just the ratios, if you have two different things and you need to see if they're similar, or if you want to see if they're similar proportional, you can use their ratios, which is you can either use A over B, or for the length, or A over B, and you square them both if you want to find for the area. And yeah, okay, this is chapter 12, and it's surface area and volume of solids, and it's pretty much exactly what the title says. It's all surface area and volume and the formulas of it to how to find them of polygons and 3D figures. And it's exploring solids and their properties, solving problems using surface area and volume, and then a sample problem and how you can use this, like if you're in the real world application, for a real world application is, so if you have a prism and it's a bad picture, but if you need to find like just what the volume or surface area is, you just use one of the formulas, and of a prism it's surface area equals 2b plus pH, which is the b is the area of the base, and then p is the perimeter of the base and the height.